What's up, guys? Welcome to OpenAI Way channel. Today we're not going to be reviewing any archived papers, but to talk about a practical issues that occurred in the speech recognition, the timestamps. As we know, OpenAI's Whisper ASR model are fairly popular right now. It receives tens of thousands stars, and there are lots of third-party developers trying to using the Whisper as a foundation model to chatter different applications. One of the things people are working on is generating the word boundaries in the speech recognition results, aka timestamps. But based on the feedbacks and the issues on GitHub, people have seen that those timestamps are not very accurate sometimes. So why is that? So today we're gonna be looking into that. And here, if you do not have time to finish the full video, but let's first look at what we are. We are a data vendor, and we generate the databases for training your AI models, not only ASR, but also computer vision and text to NLP models. We're better than the traditional vendors in terms of the data efficacy, the delivery speed of the data, and the pricing, and also we are very niche in the data service. Okay, here is the take-home message if you do not have time to finish watching this video. The first thing to remember is Whisper cannot provide reliable word stamps. I know lots of people would have different opinion than me, but if you do, just keep watching the video and post your comment in the video comment section, and I will definitely reply your questions, your argument. Okay. The second thing is the reason, because nowadays end-to-end models like transformer-based models, they use a cross-entropy based criteria, and that they are not designed for reliably estimating the word stamps. I will explain or get into the details in the following slides. And it is worthwhile noting that there are certain open source tools, and this is my recommendation. The first is to stay away from the heuristic post-processing tools, especially the ones without any benchmarks. The reason is that I wouldn't say these repos are completely useless, but I would say that their repos wouldn't help you if their thing didn't work, and there's no way for you to debug it into the right mode, because most of the time, especially the heuristic post-processing based approach, are theoretically very, very wrong, and it won't get anywhere. The second is that the phone-based post-processing are better compared to the Whisper post-processing, but it does need a pronunciation dictionary. So think about, suppose you want to use that method on the under resource or low resource language, for example, Egyptian Arabic, and then you have to get this pronunciation dictionary of that specific Arabic language. Not everybody can do that. Then you have to find a linguistician in Egyptian Arabic. It takes time. The second point is that this is not just a one model. It's an extra model on top of or after the Whisper model. It introduced extra computation cost, although it's not much, but it does increase the deployment complexity. The third thing is, this is my opinion. They are actually also theoretically flawed. They're not completely wrong. They're flawed, and that they are also have issues. And sometimes it does have, or those methods they do have, still have the word timestamp that are not accurate issue. Let's say you may ask, Wei, what do you mean by word stamp? This is a screenshot I got from the Google API. The definition is in the audio, suppose you recognize a word or you manually label the words, the time offset values of each spoken word is the word timestamp we're talking about. And you can see that indeed, definitely you can see an error in the Google shown the result. The word end has a duration of 0, you know. I think 99% of the time a word won't have a duration of 0 unless the person didn't say the word end, and you shouldn't recognize end in the final result. So, and the example of Google also tells us the word stamp is a very difficult problem. Even Google makes mistakes. Okay. So let's have a more visual understanding of what the timestamps or word boundaries we're talking about. Here's a picture I grabbed from a paper, and you can see the sun began to rise. On top is the waveform. On the bottom is the spectrogram. Spectrogram, you can view that as an image. So the x-axis is the time, y-axis is the frequency bins. I guess most of you have seen the difficultiness of the word boundary segmentation. Let's first start from the easy ones. What's the boundary do you think between the word sun and begin should be? And this is what they have labeled, and they think this is what linguistician would label. But I guess most of the people, including me probably, would move the boundaries slightly to the right. So some people, they label the word boundary on the cliff of the dark spectrogram components. And then we can tell you that most of the people are wrong because what? So there's a linguistician theory which says the B is something like a correct me if I'm wrong, okay, it's plosives, right? So you have to prepare for the B, and this duration is when you are preparing to enunciate the sound B. So this should be moving to B, not to the end of the sun. And also, the interesting thing is that you can also watch the videos of the person enunciate the sentence, and you can see that you will definitely see that person is definitely making effort to prepare to speak the phoneme B during this region. From the video information, you can see the person like the mouse like a B. Yeah. Also, we finish off from the silence or the non-voice section or non-energy section. That's the easy one, let me tell you. And then when you say this section, the sun, right? And this involves telling the boundaries between the vowel and a consonant. And over here, you can see that they put it here. But this is just, you cannot just draw the boundary by listening. You have to carefully look at the spectrogram and see where the cliff or where the significant boundary looks like. So this is why labeling those word boundaries takes a lot of time, and lots of time they require professionals, aka linguists, to label them. It's never an easy job, and the question is, can AI do it? Can AI do better than human being? Unfortunately, I think the answer right now is no. And I also want to have another extra information for you. If you guys are interested, and suppose you have the access to this database called Timid, you probably can find it online, right? Okay, but you have to pay for the database, let me tell you. This database contains about 4 hours of data, which are time-aligned. They have time-aligned phonetic and word transcription. What do I mean? So you can see over here, of course, the most right column is all about the words. These are phonemes, and these are these. The first two columns are starting and ending frames. I mean, these are the frames means that they're of a certain time unit. Probably it's 100 nanoseconds. Yeah, correct me if I'm wrong, but that's the point. You can see. So you may ask, how do you get this? Well, these things are firstly generated by running an algorithm called false alignment, and after they generate that, of course, this is a machine learning based generation of these phoneme boundaries by leveraging the expectation maximization algorithm. But definitely, they are not right all the time. So they have linguists to come here and then look at the audios and also check the spectrogram and make alterations to the boundaries of the phones, the words, and etc. You may ask, are there other databases like Timid? As far as I know, Timid is the only database, and Timid is only for US English. If you know any other phonetic label database, especially that contains the word boundaries and phonetic boundaries, please comment in the comment section to let our readers know too. Okay, why? So let me ask you, or let's ask 3 questions. First, how do we formulate the timestamp estimation problem or word boundary estimation problem in the ASR? The second question is, what have people done in this domain? The third is, what are the issues? Let's see, I think I would want to use this one. Okay, let's see how the problem are formulated. Most of the time you want to get the word stamps, you already have the transcription or the ASR result. And say we have transcription, okay? You have transcription. Let's call that. I think word piece and word of phonemes are interchangeable in my explanation, but I would just use word, okay? Word 1, word 2, suppose I only have 3 words. And these are only 3 words, okay? But in terms of the audio, I have 1 second of audio. And suppose I do framing. So that means I take a window and then move the window along the audio in a certain time steps. So suppose the step size is 10 milliseconds. Then I would have 100 frames, right? Suppose you use a frame skipping, then you have about 30 frames. So let's say I have 30 frames. 100 is easier to understand. Okay, the frame step size is 10 milliseconds. So I have x1, x2, to x100. Make sense? Then the question becomes, you want to find the word boundary. So does the word boundary look like, use another color, okay. Of course, you have to find the boundary of the first word. Because why? Because people, when these people speak, people have silence, right? So you want to know when the word starts. Okay. So say this is, so this is the beginning time, okay, 0, and this is 1 second. And you want to find the boundaries of starting time of the W1 and the starting end time of W1 and the starting time of W2, end time of W2, starting time of W3, and W3. And this corresponds to where? Certain place here, right? And suppose this is x30, and this is x51, and this is x82, etc. Okay, so then you can see that after I do this, I will probably find my first estimated results, which is W1. They goes from x3 to probably 28, right? This is starting frame and ending frame. And for W2, it start from 30 to 51. And for the W3, it's probably starting from 82 to 96. All right. So you can easily see that. So the question of word stamp estimating is you get for each x of t, what's the probability of the W given this and the condition. I will explain the condition later on. What's the probability of the WI given the current frame? And I want to get the maximum WI. Right? That's the fundamental issue. People may say, okay, wait, what do you mean by the condition here? I would say the condition means it doesn't make sense to just look at the frame by itself, because word is always in a contextual sense, and it dependent on adjacent words and sometimes the whole utterance. Okay, and let's say what the whisper does. I have a paper talking about whisper, reading the whisper. I have a recording reading the paper whisper in my OpenAI Wave channel. You can definitely go ahead and check that. I think this is probably the most extensive paper reading that goes into the details of whisper, other than tells you how to call the whisper model on how to use the whisper for your own applications. It's digging deep into what the whisper does. And in that paper, let's first forget about how the word stamp is estimated. What they are doing is and they're using an autoregressive method to estimate I think this should be word WI. The probability of the WI is being calculated by WI minus 1 to I1 and given X. What do I mean by X? X is X1 to 100 in this case. Why? Because Whisper model is a non-streaming model. To get the ASR output, it needs to look at all the audio frames other than just looking at a current frame or adjacent frames or blocker frames. Then it will get the most likely words. But definitely it's nothing wrong to use this framework for speech recognition, because most people, they do this in this way. But the issue is that you can see the condition. So you can see this one, I can rewrite this as WI to W1 and X other than XT and XT, right? These are the conditions we talk about when you're using the Whisper to estimate the time boundaries. And I would say for these, the time context is too long. Well, imagine that we have look at this the word boundary determination in the slides I showed you before. I think to determine the word boundary, you only have to look at a span of not more than 1 second in my case, right? Only the words next to it or adjacent to it. You don't have to look at words that are 10 words away from this, but Whisper does. Because you can definitely send the 20 seconds of audio into Whisper, and that usually contains definitely more than 60 to 100 words. So you can see it has a lot of too much context fed into the Whisper. Of course, it's good for raising the ASR accuracy purpose, but I think too many irrelevant information can be affecting the estimation of the word boundary. And also you can see this. Like I said, most time the 1 second is enough, but in this case 1 second is probably enough. But in the Whisper, you have another 19 seconds also gotta be fed into the estimation of everything, right? So it's not that ideal, okay? And I think if you look at another paper they called so you may ask what Whisper actually did. They use attention weights. I put it here, yeah. Let me explain to you the attention weights. It's easy to understand. This is the Whisper's official repo. You go to Notebook and Multilingual ASR, IPyDB. This is the setting. Where's the key algorithm? Yeah, over here, right? Those are the weights of from different layers, and then they run the median filter and run norm, and then they run the alignment, right? So the issue of the attention weight is, in my personal opinion, is even worse than using this equation. Using attention weight, the issue is what? Attention weight. Let's say I give you example, San Francisco. I want to estimate the starting time and ending time of the word San or the word piece San, okay? Because the Whisper model is being trained using the whole context or the global context. So if you look at the attention weight of the San, it's very much heavily reliant on San Francisco. Why? Think about this. Suppose I have already, somebody said Francisco. It's very likely the word ahead of it is the word San. Makes sense. So you would see that the attention weight, if I draw on the time axis, the San's attention weight might be looking like this. Of course, the San itself correspond to here. Suppose that this is the real word boundary of the word San. Okay, this is the real. Let me use another pen. But if you look at this, because San's attention weight is heavily dependent on not only the frames of itself correspond to the real boundaries, but also it's heavily dependent on the word after it. Then you would see that because attention weight is shifted the right way, okay, then it's very likely the time boundaries is being shifted into this domain. Well, you can check it yourself, okay? This is my explanation of why the timestamps are not accurate in the Whisper and also other end-to-end based models, because they use attention weights, and those attention weights would block the algorithm from estimating the real word boundaries. But then you ask, wait, oh, I know, CTC loss. I watch your videos, and I know Dr. Alex Graves has his classical paper is called Connection Temporis Classification. CCC has no attention. Would that work? I would say you are a loyal reader of my channel. Thank you. And definitely you can see that CTC approach is more follows this direction, right? You remember that CTC, they also use the full utterance or full utterance frames, or they use all the features from time to 100, the first frame to 100 frames. In this case, for estimating the probability of WI, but it can also run frame by frame, but it won't be very accurate. And for CTC, suppose you just use a CTC without language model. I think then your PWI is completely like this. Okay. Then I would say it's bad or good, because you do want to know the word before it and after it. Just to look at the current word, it's not, or without a word context, it's not good, because even our human beings, we look at the spectrogram, we also take a look at what's the word before and after this current word. That's the one issue here. This is called word history or word context missing. But then when you say, suppose, what if I have the word language model? Again, you have the same issue like Whisper. You have too many word contexts, right? Context. Processing. Then you can see that of course when CTC doesn't use attention, it might be better. And actually the news is that CTC is better than the attention-based method. This is my experience. But I do not have any solid benchmarks because I do not have time to run them. CTC is better. Than attention weights. But does CTC fully resolve the issue? No. Like I said, and the word context issue, and also there too much what do you call that? Too much audio context, right? Okay, this is called audio context, right? XC is audio frames, audio context. So you ask, wait, what if I just limited the context? Then you suffer from the drop in the ASR accuracy, right? This is like a dilemma. You want to have better resolution over the word boundaries that you are interested in, but you lost the whole picture. Then you are suffering from the WER increase. How do I get another page? Okay. So you ask, wait, what are the possible solutions? And let me see. Getting away. Okay. Another one. So let's look at the question again, right? Because all you're interested is PWI given x of t given the context. The context has to be proper. I think one thing you can look into is something called a generative model. It's not the generative AI, right? It's versus the discriminative model we're using right now. All the end-to-end based method right now we're using are discriminative model because they only care about estimating the posterior probability other than the conditional probability. For generative model, they try to estimate the conditional probability, and definitely you go from the conditional probability x of t of wi in the context. But this way, you don't have the context. Okay. And then in the generative model, you estimate this one. And indeed, for most of the generative method in the ASR or false alignment, you would not estimate this one. And you are trying to estimate, you first go from the word using the phonetic dictionary, pronunciation dictionary, to the phonetic, the current phone, okay? Phone J. Of course, one word can have many phones, several phones. And then for each phone, because suppose you're using the left to right, 3-state HMM, and then you can further map each phone into certain states. SK. So each phone can have 3 states. Then in this way, you turn the estimation of this probability into this one. Okay. The benefit of this is that you can further rewrite this equation into That makes sense? This is called rover system. You have a weighted system. Then you can just, this is purely from the acoustic. This is purely from, you can call it linguistic or language, because this condition this time became just a word history or word context. Okay. And for this one, you can definitely see that you just convert this into this one. And this one, the good thing is that suppose you're using HMM, because you use a generative model, it tries to model the underlying phonemic duration or the state duration of a phone in a mathematical way. You build a model for that. And in my personal experience, if the audio is not very noisy, this model is very good in terms of estimating the duration of the phone. Okay. Or false aligning the duration of the phone given the audio and text. And which means it can generate the word boundaries better. And you can further improve this model. And you know, this is a conditional probability, right? Then you further convert this into this one by using the Bayesian rule, right? This way you use the Bayesian rule, right? Bayesian, right? Bayesian. Use a Bayesian again. You got this one. Then you got this posterior probability, right? As we know, though, if you trying to estimate the posterior probability, then you can train neural network out of it. So you can train another transformer model again to estimate this. Okay, makes sense. But remember this time for this transformer, the context is not how do you say? It's not it's not the whole utterance. It's probably just the XC itself. The XC doesn't have to be the current frame only. It can be the XC plus a couple of frames adjacent. So in this way, I think this is probably the solution to it. But definitely this way, the model became more sophisticated. And also, let me tell you, the other issue this thing might have is that when you discard the word context, right? So you're just trying to estimate this one, then this one became unstable again, right? Because you lose context. The context is not sufficient. Then you especially when you go to this mathematical model HMM, that you suffer from the modeling inaccuracy. And then sometimes I think, how do you say that? Dataset-based approach is not perfect either. But according to my experience, this approach is better than the CTC-based alignment if the audio is not very noisy. All right, I'm going to stop here. If you have any other questions, please feel free to comment in the comment section. If you like our paper sharing and question discussing, please subscribe our channel and also share the video with your friends. Thank you so much, and I will see you next time.